meets the curve at infinity. Okay. So here, okay. Like if you see, okay, example, you can see, let's take a simple example. You can see now. So here, y equals to 1 by x. Okay. Simply, if you x approaches to 0, this y will approach to infinity, that you can see from here. So what will be the curve if you see 1 by x? So the curve will be something like that. Okay, we will consider here x approaching to 0, 1 by x. Okay, so the curve will also approach to 0. It will be like this. Okay, here also, right? So it is approaching to positive y-axis. Here also it is approaching to positive x-axis, but they will never meet. Okay, but it will approach. You can say they will meet at infinity. So these are known as the asymptotes here. And you can see here also negative x-axis, negative y-axis. Okay, you can say they meet the curve and the straight line. They meet at the infinity. Okay, so these are known as the asymptote to the curve. Okay. So suppose we have, okay, if you look at the formal definition, okay, any equation given to us, we will write g of xy equals to 0. It's the implicit form. Okay, the equation is it implicit equation. You can also write it as y equals to fx or x equals to hy form. Okay, now here you can see this example. Okay, if the distance of curve from a straight line L tends to 0 as x or y or both xy approaches to infinity, then the line L is called the asymptote. Okay. Now here only it's a very easy example. You can see x and y axis are the asymptotes. Okay. So here you write down this one. If the no, I'm writing. If the distance of curve from a straight line. Okay. So simply this asymptote and the curve, they meet at infinity. That's what we say. Tends to 0 as x or y or both approaches to infinity. Then the line L is called asymptote of the Okay, so we have three types of asymptotes: vertical asymptotes, horizontal asymptotes, inclined or oblique asymptotes. So here you can see this y-axis is the vertical asymptote, and any line parallel to y-axis will be the vertical asymptotes. Got it? Like here, if you have the curve like this one, okay. And so any asymptotes like this one. Okay. So if you remember, you have seen many of the curves like this. Okay. So this is how it goes. So they are vertical asymptotes. Okay. This is how the vertical asymptotes will look like. Okay. They are parallel to x-axis. Okay. And similarly, if you look at here parallel to x-axis, they will be the horizontal. Okay. Horizontal asymptotes are parallel to x-axis. And we will also have some asymptotes, okay, which are not parallel to x or y axis. They are known as inclined or oblique asymptotes. Okay. Let me draw here. So this is y, this is x. So for the vertical asymptotes, examples, it's parallel. Okay. So here. So if you remember tan x also this type of graph, I think. Okay. I
Yes,
think
yes.
pi by 2 is the asymptote. So this type of asymptotes will be vertical asymptotes. Okay, examples. For the horizontal asymptotes, it's parallel to x-axis. All the asymptotes which are parallel to x-axis. Okay, so you can have the curve like this. Okay, so these are and inclined which are not. Okay, you can make it this one. Okay, so this type of or your curve can be here. So this one. Okay. So this is how inclined. Okay. So now you have some idea. So how do you know about asymptotes before?
Yes, ma'am. Yes,
So
ma'am.
this
In
this is
hyperbola, in
But
hyperbola, we know.
okay.
yes, ma'am.
And the formulas how to find asymptotes? Three types of asymptotes, and we will have the formulas to find the asymptotes. Okay. Okay. Let me give you how to find the vertical asymptote. If you have given the equations, so the asymptote is the straight line. Where the curve and asymptote they meet at infinity. That's what we say. Or the distance between the straight line and the curve becomes zero. Okay, as they go to infinity. So vertical asymptote. So normally you will have an implicit function, and you can write in this form y equals to fx, and you can also write it px by qx form. Okay. Now if limit x approaching to a f of x approaches to plus or minus infinity. Okay. Then the line x equals to a, it's called a vertical asymptote. To curve y equals to fx. Now we have to find this a. Okay. So any idea how we can find this a? By looking at the equation. When fx approaches to plus infinity and minus infinity, x approaching to a. By looking at the equation, what you can say?
And Qx tends to 0.
Qx tends to 0. So when x approaches to 0, Qx tends to 0 means what we are getting? X approaches to a, Qx approaches to 0. That means a is the root of Qx, isn't it? So if you
Yes,
look
ma'am.
at here, what we are getting, x approaches to a implies Qx approaches to 0. So that means a is x equals to a is a root.
QA is
So
equal to
this,
0.
yeah, what did you say?
No, ma'am. QA is equal to 0. That ma'am.
Qy.
QA, ma'am.
Yeah, QA equals to 0. Or I will write QX approaches to 0. Okay. Okay. X equals to A is a root of equation qx equals to 0. So if you have any equation which is like fraction form, directly you can look at the denominator term and is there any root, so you can directly get it, or you have to reduce it to that form. Okay. And this example is here, there is one thing also, order of the root. Okay. Order of the root means if you have x minus a, what is the power of x minus a? That will be the order of the root. Okay. And that order of the root also gives you some idea. You see, if it's odd and even, there will be some idea. So here, if this root is of odd order, what happens? Of odd order. We will do one example also. Order. Then the curve approaches the opposite ends of the asymptote. From the two sides of the asymptotes. From the two sides of the asymptotes. Okay, two sides means both left and right. Let's look at the example. Both we will see. We will look at the vertical one also, and this one. Odd order. Suppose y equals to fx. And fx is given by 1 by x minus 1 cube. Okay. X equals to 1 is of order 3. Okay, x equals to 1 is of order 3. Okay, so now you see what you can say about the asymptote. As x approaches to infinity, fx approaches to, x approaches to 1, fx approaches to infinity. Okay, so we have x equals to 1 is this x equals to 1 is a
Asymptote.
vertical asymptote. Okay,
Vertical.
because you see, this is what
Yes, ma'am.
limit x approaches to infinity, fx goes to infinity, then the line is called vertical asymptote. So which what you will say is x equals to 1 is vertical asymptote. Now if you draw this graph, okay, it's of odd order, and what we are saying is if your a is the this 1 is of order 3, it's a root of order 3 of x minus 1. Okay, odd order. The curve approaches opposite ends of the asymptote from the two sides of the asymptote. Okay. So you see two sides means we will see what happens when x approaches to 1 plus, what happens when x approaches to 1 minus. That means from the right hand limit and the left hand limit. Okay. So if you draw this one, the graph will be like this. Okay. So the graph will be like this. Okay. So here this is x axis This is y-axis. This is x equals to 1. Okay, and this is your y. This is also y. Y means fx. Y equals to fx. Okay, right, y. Okay, so this is the curve for y equals to x minus 1 cube. Okay.
Ma'am, that graph on the left side, it should terminate before x equal to 1, no? Yeah.
Oh, sorry, sorry. It should go to that
Yes,
side.
ma'am, it we should go.
Go to
Here,
x equal to 1.
not the y-axis. It is x equals to
It
1.
is with the x equal to 1.
Because it will approach to the asymptote from
Minus
both
infinity
sides.
at x equal to
Yeah,
1. Huh.
yeah, yeah. Okay. Draw it properly. Okay. It will be like this. What I'm trying to show is it's asymptote. I'm sorry. Okay, I made it a y-axis. Okay. So here you can see it is from both sides. That means you can see x approaches to 1 plus. If it is from the plus side, it is approaching. That means this right side, fx approaches to plus infinity. It goes to plus and infinity as x approaches to 1 from the right side and x approaches to 1 minus, that means the left side. Then fx approaches to minus infinity. Here goes down. Okay. So you can see what I'm saying is if it is of odd order, the curve approaches to asymptotes from both sides. Okay. So here you can see from the right hand side and from the left hand side. This is how it is. Okay. When I'm saying. So if this is this way. Okay. And if you look at the curve, we are also able to see one more asymptote is there. Which one?
X axis.
X-axis
X-axis.
also there. Okay. Um, okay, okay, let me write this
That
one.
is
So this
horizontal asymptote.
that is horizontal one. We will come to one, but by looking at this, we can say
Yes,
there is one more asymptote. Okay. So here you can write. Therefore, the curve approaches the same end of the asymptote x equals to 1. Opposite ends of asymptote from two sides of the asymptote approaches the opposite ends of the straight line x equals to 1 from the two sides of the asymptote. Opposite ends of x equals to 1. Okay. This is one end and this is one. It's the opposite end. And from two sides. From the two sides of asymptote. This is asymptote. X equals to 1. Okay. So whenever odd, this is the scenario. Okay. So it approaches to both opposite ends of the asymptotes and from both sides. Okay. Now we will look at the horizontal one. Okay. So we have horizontal asymptotes. So just the opposite. Once you change the place of y and x, you will be getting. So horizontal asymptotes. Okay. So here what we will do, the implicit equation g of xy we are writing here. Okay. For the vertical asymptote, we are writing y equals to fx. So for the horizontal one, we will write x equals to fy or hy since we have already used f. So x equals to hy and it will be of the form py by qy. Okay. And the same manner we will look at the roots of the qy, they will form. Okay. So whenever limit x approaching to b, this hy approaches to plus or minus infinity, then this x equals to b line will be the horizontal asymptote, okay? Either x-axis or parallel to x-axis. Sorry, y. Okay, this is y. I have written x. Then the line y equals to b is called a horizontal asymptote. A horizontal asymptote to the curve. So y equals to b is the root of qy. Okay, this implies y equals to b is a root of qy. Okay, the same process as we did the previous one. So y equals to b, if this happens, it's the horizontal asymptote. In the same manner, we can look at the same one. Okay, since we have done, we will express the equation in terms of. So here, that one is given f of x equals to 1 by x minus 1 cube. Okay, so the same one we can write as x minus 1 equals to 1 by y power 1 by 3, or further x equals to 1 plus 1 by y 3. Or if you want to do the simplification this way, at least we will have a term in the denominator, and you can see what we are getting. Y equals to 0. Directly you can see the look at the equation, and you can say y equals to 0 is the horizontal, that is x-axis is the horizontal asymptote here. Okay, and we will also say what happens. Okay, because order, if you go order it cube, y will be y equals to 0 will be third order. So whether the curve is approaching to x-axis from both angles, yeah, you can see if x-axis is the asymptote and this curve is approaching to x this way, so from plus side this is what happens, and from the negative, so the curve is approaching to the asymptote, opposite ends of asymptotes from two sides. The same thing is happening. This is the odd one. So here you can see as y approaches to 0. So we are considering h of y. X equals to h of y. H of y approaches to infinity. This implies y equals to 0 is horizontal asymptote. Okay. So here y approaches to 0 plus. Okay. From this, like from the upward. Okay, if it is approaching to 0 from this angle. Okay, from this one, if it is approaching to 0 this way, it is hy approaches to plus infinity, and y if is approaching to 0 from the minus side, then hy approaches to minus infinity. Okay, so you can see y power 1 by 3 is well defined. Okay, for non-zero. Okay, so therefore the curve approaches the opposite ends of the horizontal asymptote y equals to 0. So you can say. Similarly, like we did for the vertical one, therefore the curve approaches the opposite ends of horizontal asymptote. Okay, so now we will come to one more. Okay, the even order. Okay, this is for the odd order. Okay, whenever odd order, opposite ends of the straight line or the asymptote, the curve will approach. Okay, from both sides of the asymptote. Okay, now if you have even order, what happens? Okay, if you have even order, that means the root, you are saying the asymptote is of even order. Okay, if the root is like you are saying y equals to fx by qx, okay, and the root is of even order, if the root of qx is of even order, okay, that means like their x minus 1 power 3, it can be 2 or any even number is of even order. Then the curve approaches the asymptote from the same side. The same end of approaches the asymptote, same end of there it was the opposite end of the asymptote, here approaches the same end of asymptote. So it is one good idea here, asymptote from the both sides of the asymptote, from the both sides of the asymptote. So for example, we will consider y equals to, so the same example, okay, similar example. There we consider 1 by x minus q, here we will consider x minus 1 square. So you can see here,
Ma'am, for this case, we can also tell it will be symmetrical about the asymptote.
we can say that, but it may not be symmetric for this particular case, okay. The
Yes,
power is square, then you can have some other like for this particular asymptote, suppose we will multiply here x minus 1 square into x cube, you see, it can be also this, right? For one it is
yes, ma'am.
symmetric, but there can be other part of the curve, got it?
Yes, ma'am.
So the only thing about the asymptote, it will approach, but then we don't know what happens.
Yes,
For
ma'am.
this particular case it is symmetric, for this particular case when you have only one term, okay.
Okay.
So if you draw the curve here, we can see x equals to 1. This is x equals to 1.
Ma'am, can you shift your note a bit upwards?
Some more.
No, ma'am, no, ma'am. Yes,
This
ma'am.
at
This.
the end you remind me so that I can send you. Okay, any one of you will get that PDF or I will share it. Okay, then you can share. Okay, so here this one. Okay, it's a similar. Okay, there only thing here if you draw x minus 1 square, so it will be like this. The curve will be like this. First I'm discussing with one example. Okay, and here also this one symmetry.
Ma'am, if f of x was x by x minus 1 whole square, then?
Then only x minus 1 square 1 will be the asymptote. Okay, x equals to 0 will be of odd order. Got it? Y axis will be asymptote, but it is the order is 1. Only this part will be like this. There can be more than one, okay? Only for this one. I told you, na, if xq will be there, then that will be different case. Or you can have other expressions also, whole expressions. Got it? This is only we are discussing what happens if you have a asymptote of even order. So you can say the curve will approach to the asymptote from both sides to the same end. Okay, if even order. If odd order, to the opposite end, this one and this one. But if it's the even order, then here only one end it will approach from both sides. Okay. Okay, like this. So here you can see we will write the curve approaches the same end of the asymptote x equals to 1. X equals to 1 is asymptote of order 2, okay, even order. Okay, so the curve approaches the same end of the asymptote. X equals to 1. Okay. And here you can see x-axis is also, by looking at this one, x-axis is also the asymptote. And you can see the curve is approaching to x-axis, the opposite sides, but not from both sides. Got it? So you try to write it down in the other way and you can find it that. Okay. So here it will be like x minus 1. You want to write this one, x equals to 1 plus minus 1 by y power half. Okay. And so further you can write y power half plus minus 1 divided by y power half. So this is your hy. So y equals to 0 is the asymptote. Okay. So hy you can say is not defined for y less than 0. Got it? Hy is not defined for y less than 0
Yes.
because it is square root. Okay. So here hy not defined for y equals to 0, y less than 0. So as y approaches to 0, plus side from hy approaches to plus infinity. Okay, so therefore the curve approaches the opposite ends of horizontal asymptote y equals to 0. And x-axis is an horizontal asymptote of the curved run. Okay, it's not of odd order, so here you cannot say that. Okay, and there is one thing, it's not defined for y less than 0 from only one side. You see, if y is approaching to 0 from this side, okay, but this side it's not defined, so there is no opposite side. So therefore the curve approaches y equals to 0, that is x-axis. The opposite ends of the asymptote. to the opposite ends, not from the opposite side, only from one side, because the other side is not defined. Or the curve approaches the asymptote to the opposite ends. Okay, now we will come to the third one, inclined or oblique asymptotes. So other one which was not horizontal or vertical, it's inclined or oblique asymptote. So here it's not defined from other side. Okay, that's why we are getting like this. But for the like x equals 0, it's defined from both sides. So now we look at inclined and oblique asymptotes. Okay, so here if the equation g of xy equals to 0, the implicit form is given to you. And we can further write these. Okay, y equals to fx form. Okay, and we solve it. Okay, we write it z of xy. It will be given to you as an implicit form, or sometime if it's given y equals to fx, then it's good. Otherwise, you reduce it to y equals to fx. Okay, and now let y equals to ax plus b be the inclined asymptote here. Okay, so I'm not going to further derivation. I will give you the formulas. Okay, so here what happens? So this we need this the value of this a and b. So what we do here, a will be same as the limit x approaches to infinity fx, okay, and b equals to limit x approaches to infinity fx minus ax. Okay, so previous one is the modulus sign, and here we don't have, for b we don't have the modulus sign. Okay, for a we have the modulus sign. So if you want to find the inclined asymptote, you can consider it like this. Okay, and we have one alternative way also to find. There is one alternative way. Okay, so this is one simpler one. If you look at the equation, you can find it. Okay, so suppose our y equals to fx, it's in the fraction form, then it's easier for you to find the asymptotes. Okay, whether it's the vertical one or the horizontal or the oblique one. Okay, and here you can see px. That means we are considering the well-defined form qx not equals to 0. It will be 0 at some point. There you get the asymptote form. Okay, so I didn't write qx not equals to 0 form. Okay, since qx 0, we will be getting the asymptotes. Okay, and px and qx are polynomials in x. Px and qx, they are the polynomials of x, of x. Okay, now the degree of px, okay, degree of px be 1 unit greater than 1 unit greater than so degree of px minus degree of qx. Okay, equals to 1 exactly. Okay, if you go for the higher thing, that will be different. So what I'm saying is degree of px minus degree of qx is 1. Then you can divide px by qx. Then this fx, if you divide, you can write fx as ax plus b into plus rx by qx. Okay, so this way you can write. So what happens here? The degree of Rx is less than degree of Qx. Okay, so whenever x approaches to infinity, Rx by Qx will approach to 0, right? Degree of Rx is less than degree of Qx. So when x approaches to 0 or plus or minus infinity, plus minus infinity, so this term Rx by Qx approaches to 0. Okay. Rx by Qx will approach to 0 since the degree of the polynomial Qx is greater than Rx. So this term will approach to 0 and the distance between the curve y equals to fx. See, and the distance between so the distance between y equals to fx and ax plus b goes to 0 as x approaches to infinity. So y equals to ax plus b is an oblique. So this is one way you can find or inclined asymptote. So this is one way you can find, okay, the inclined asymptote. Okay, you look at the equation and if it's possible, use this one and it's easier. Y equals to ax plus b. Simply you have to reduce this equation px by qx to this form. Okay, and then you are getting this ax plus b as the your asymptote. Okay, it's one of the easier way. Okay. So for example, you can consider y equals to 3x squared. So whenever it's in the fraction form, it's easier for you. Okay. So you see, you can further write this one as 1 by 2. Divide by 2x. If you divide by 2x, 1 by 2 you can take. So here it will be 3x plus 1 plus 5 by x. Okay, so this is your residue Rx by Qx form. Okay, you can make it 2x also. So here, as x approaches to infinity, x approaches to 0, y approaches to infinity. Okay, so as x approaches to 0 plus y approaches to plus infinity and x approaches to 0 minus y approaches to minus infinity. Okay, so therefore x or y axis. So x equals to 0, which is same as y axis, is a vertical asymptote here. Okay, so by looking at this one, okay, first you look at the denominator term and equate it to 0. We are getting x equals to 0. So y x equals to 0, that means y axis is a vertical asymptote. And now 5 by x, and now if you put, so this is 1, x equals to 0 is a vertical asymptote. Now x approaching to infinity, what happens here? X approaching to plus and minus infinity. Okay, 5 by x term approaches to 0. So y equals to 3x plus 1 by 2 is an inclined asymptote. Okay. Now there are one idea, like you may say that curve is, so this is the examples we have done for one. Okay, the more examples we will do. Okay, we have the class. Okay, that evening class is on. I say that 3 to 4. Okay, I said that.
Yes, ma'am.
Yes, ma'am.
Okay, okay. 3 to 4 class today you come. Okay, we will do the examples there because I already discussed how we find the horizontal and vertical asymptotes. Okay, and otherwise I have to take on Saturday. So that's why I wanted today. So here
Ma'am, in this example, is a horizontal asymptote
there
also
is one
possible?
horizontal is possible here. First one we did for the horizontal, right? X equals to 0 is a vertical asymptote. Okay. First one is the vertical asymptote. Then we go for the then we tried, since it's a fraction form, whether inclined asymptote is there, that you can try. Okay, both are polynomials, so we tried, and we are getting one inclined two asymptotes, x equals to 0 and this one. Okay, and one thing also you remember, you don't think that curve is not intersecting that or not crossing the asymptote. This is not the way. It can also cross the asymptotes. Okay, like this one, you can also, it is possible if you have like it may go like this one also. Got it? So here it can intersect and here it can be the asymptote in one end. So don't think that it won't. Okay, so you just remember this is also, don't think that. So the graph of a given curve may intersect an horizontal or inclined asymptote. Okay. And there is one thing, if the previous what I discussed here, this one, it's important that this one, the degree of numerator is greater than the degree of denominator only by 1. Okay, it's not more than 1. Okay, if it is 2 or more units higher than the degree of the denominator, then there are no horizontal or inclined asymptotes. Okay, this one is important, that it must be equals to 1. So if it is more than 1, you are not going to get in horizontal or inclined asymptotes. Okay, so you have to take care that this is 1, then only you use this form. Got it? This ax plus b that you are getting directly, only it happens for this. If the difference of degree is 1, exactly 1. If it is 2, you are not going to get it. So just remember this one. Okay, first one, the graph of a given curve may intersect an horizontal or an inclined asymptote. This is one note you have to remember. Okay. Don't think that it only meets at the infinity. It's possible that it can meet from previously. Okay, and the difference of degree of px minus degree of qx, if it is greater than 2, greater than equals to 2, then there are no horizontal or inclined asymptotes. Okay, this is one easy thing you can understand. Then there are no horizontal or inclined asymptotes. Okay. So we will do the examples and okay after lunch. Okay, 3 o'clock class and few examples we'll do and okay. So wait, 4 minutes time we have. Just a minute. How many?
Ma'am, please show that last question again, that fraction one.
You tell me and I will share. Okay. At least one of you I will send it directly and you will see. Okay. You tell me your roll number and you will share it with your class.
Ma'am, 29.
Full. Yes.
B1211029.
B1 then
21.
21.
Yes, yes, ma'am.
Then
029
then this one.
at the rate triple ITBH.
And then I
Hmm.
will. Right? This roll number is right. I'm sending. Okay. I shared it with you. You share with the class. Okay.
Yes, ma'am.
Why this send a copy option here? It is coming.
Ma'am, about the mid-semester syllabus and exam pattern.
Don't ask me exam pattern. No, it will be from the short to long questions. And why if some question are directly for the 5 minutes, 5 marks, some will be half 2.5, 2.5. Okay. So there, I till now I have not made the questions. Okay. So don't ask me that question.
Ma'am,
Questions you
syllabus.
prepare it. Syllabus what I will complete. Okay. Because only your class, because I missed. Again, you say this the last class note also I want to send. So I'm you are from this. Huh?
Yes, ma'am. Yeah, ma'am, you have shared the complete notebook with us.
So you are able to see
Yes, ma'am, it
Yes,
gets updated.
all the things, right? Ane, what I mean for today's class also you are able to see.
Yes, ma'am.
Okay, then it's okay. How I said again I forgot where I said.
ma'am, previously you have shared the one time you have shared the complete notebook with me, and I then forwarded it to the complete class.
What I did is then I didn't do it with other classes. How did I say it? That also I don't remember. It's okay. It's okay. If you're able to see, that's fine. Okay, I don't have to bother. Okay. So for the see today, if you do this first module will be complete, and I want to since in all the classes, I think it's a third module or second module. I don't know. Let me ask because ITC third module is about to complete and your I will be teaching you. So at least I will start. Okay, we have time. It's two, at least 4 5 classes we will do a few. Okay.
Ma'am, next which module you will
Ideally I should start the second module because it's the one variable calculus, the other one is multivariable calculus. But if it's the differential equation, that's also no. So that one is much easier. I don't know. I will telling you. Let me talk to them first. Okay.
Okay, ma'am.
Whether we are going for the common question or I will do a different question for you depending on that. Okay. Tomorrow, let me complete first this first module. So I'm
Okay,
ending
ma'am.
the class. We'll talk in
Thank
the
you.
next class.